Good afternoon. I am Dr. Kanampiu, a faculty member here at the Computer Science Department at WSSU. I'm here to present my data science infusion in computer science colloquium in the CADS 2022 symposium as a faculty adopter. Again, thanks for inviting me. So I'll start with the course intro and class composition. The Computer Science Colloquium, CSC CIT 1105, concentrates on broadening students' general knowledge of computing fields and computer ethics, as well as developing critical thinking and problem-solving skills using current technologies and computing tools. For spring 2022, the class was composed of a total of 22 students, composed of 65% males, 35% females, and 91% Black or African American, 61% composed of computer science majors, IT 35%, and psychology 4%. So the goal and the expectation. The immediate goal was to introduce the students to this emerging field of data science and analytics in a guided step-by-step experiential modular methodology. So the broader objective was to prepare the students with the knowledge and skill for scholarly workshops and symposiums, next level courses, or maybe even to motivate them to consider data science and analytics in their future research study and career decisions. Special emphasis was exposing the students to cloud computing by way of Google Colab platform. The modules. It was composed of two modules. The first module was Introduction to Data Science and its Applications. Here, we dealt with the introduction to data science, the overview and trends, using resources from the WW3 schools, and then introduction to Python, machine learning, and libraries, also resources from the 3W schools. Then module 2 was about data acquisition, data cleaning, data manipulation, and visualization. This composed of acquiring and reading data sets, data acquisition methods and procedures, data frame objects, data cleaning, data visualizations and interpretations, and finally, data correlations. So the modular syllabus was more like what I have on this table. January through February, we plan to deal with data science analytics, exploring what is data science and analytics and its applications. We also wanted to explore data scraping and also explore machine learning. Then in February through March, the idea was to create and import reading data sets. So it was about creating data frame objects in Google Colab, Jupyter-based notebook using Python libraries. Then March through April was about data cleaning, where we had to clean data using Python libraries. And then April through May, our plan was to visualize data behaviors and trends, again, using Python libraries. And finally, we plan on doing linear regression, which is composed of computing and using linear regression fitting to predict results, also using Python libraries. Now the tools used. Students were introduced to Colab, Google Collaboratory, which is Python Jupyter Notebook based for labs and assessments. This free cloud platform enabled our students to comfortably use the Jupyter Notebook based data analytics tool without the concern of downloading or having to worry about any installs. All they need was just internet access and a browser. The resources, again, is the Google Colab, which we have a link to that platform. which is invaluable, like we said, because students don't have to worry about any installs or downloads or anything. They can actually complete this work just using their cell phone. Okay, labs and projects. Our labs consisted of various mini project tasks. All this was aimed at teaching and streamlining the required steps needed in analyzing a data set. So including acquiring, cleaning, manipulating, visualizing, and analyzing data sets for actionable information. The projects, students exercised in applying their new learned skill and tools in extracting suggested data points for actionable information, of course, given some data sets. The final project, students imported, cleaned, manipulated the national COVID-19 data set to explore actionable information on the correlation between vaccination and daily deaths in the United States. Again, here we use some data resources from the link posted there, and it composed, it's extracted. We extract the raw spreadsheet data for the project and provided it to the students. The study results and assessments. So the scale assessment was in form of quizzes, lab assignments, oral presentations. Students were assigned weekly mini projects, labs. Students presented their final project in an oral presentation format. Study results and assessments continued. Scale assessment modality. The lab assignments, quizzes, or oral presentations were used. Students did quizzes and presented their completed lab assignments. Students presented their final project presentation in a class formation presentation format. The final project, 67% students passed with a grade of 70% or better, and overall intervention grade, which was composed of weekly and final project, 67% students passed with a grade of 70 or better. Here I have an example of intervention assessment from the pre and post survey results. For example, here, the question was, I understood how the data science topics covered in the course could be utilized for societal goods. For this particular question, 61% or 61% was the number for the pre, and 87% was the number for the post. So basically we are saying more students did understand more how the data science topics covered in the course would affect societal good. The second one, I know what data science tools are available to solve problems in my major. In the pre-survey, that was 47% of the students. In the post-survey, 87% of the students knew what data science tools are available to solve problems in their major. And the last one, 4% of students think using data science skills is boring, while in the post, none of the students, 0%, thought using data science skill was boring. We acknowledge the University of North Carolina UNC Research Opportunities Initiative Award, Winston-Salem State University Center for Applied Data Science, FY 2020-2023. Thank you. Any questions?